Hello everyone, this is Yali Wang. This video is for Solution 1 of Homework 10 of EL 6303. First question, I need to collect the definitions and the simple properties of examples of stochastic processes. For example, Poisson process, Poisson increments, and the normal process. Firstly, for Poisson process. Poisson process represents the number of occurrence of a real event in an interval 0 to t. For example, arrivals of cars, arrivals of customers, and the queuing theory. X of t equals the number of 0 to t. So it's n is very huge, but the probability is very low. So it's called Poisson process. The properties is firstly the number n of t1 to t2 of the points ti in an interval t1 to t2 of length t equals t2 minus t1 is a Poisson random variables with lambda t. The probability of n of t1 to t2 equals k equals e to power minus lambda t times lambda t to power k over k to integral. The second one is if the interval t1 to t2 and t3 to t4 are independent. So we can get the random variables n of t1 to t2 and n of t3 to t4 are independent. So secondly, the mean. So the expected value of x of t equals lambda t, which is a linear function of t. For example, when we count the arrivals of customers, the time is longer, the number of arrivals of customers is larger. 3. The autocorrelation function. The R function of t1 t2 equals lambda 2 power square t1 t2 plus lambda times a minimum of t1 t2, which is not a function of t1 minus t2, and the expected value is not a constant. So Poisson process is not WSS. For the second one is Poisson increments. Poisson increments is the definition is the increments in Poisson process are independent. For example, x of ti minus x of ti minus 1 until x of t0 are independent. X of t is a Poisson process. C is a fixed constant. So we can get the y of t equals x of t plus c minus x of t over c. The probability of y of t equals n over c equals the probability of x of t plus c minus x of t equals n. It equals e to power minus lambda c times lambda c power 2 power n over n integral. N equals 0, 1, 2, and the expected value of y of t equals lambda, which is a constant. The autocorrelation function is 1 over c2 power square. C2 power square expected value of x of t1 plus c minus x of t1 times x of t2 plus c minus x of t2. For t1 plus c is smaller than t2, we can get the R function is lambda 2 power square. For t1 plus c is greater than t2, the R function is lambda 2 power square plus lambda 2 power square over c minus x lambda times of t2 minus t1 over c2 power square, which is a function of t2 minus t1. So since the expected value of y of t is lambda is a constant, so we can get for t1 plus c is greater than t2, y of t is WSS. 3. For normal process. For normal process, the definition is a process of x of t is called normal if the random variables x of t1 until x of tn are jointly normal for n and the t1 until tn. The stochastic of a normal process are completely determined in terms of its mean y, in terms of iota of t and out function Rx of t1, t2 is expected value of x of t equals delta of t. The out of correction R function is expected value of x of t1 times x of t2. That's it. Thank you.